All right, ACT warm-up number 5. Number 1, at dawn, the temperature of the summit of a mountain was at negative 8.5 degrees Celsius. By noon, the temperature had increased to 7.6 degrees Celsius. That means to go up. What was the temperature at noon? Well, we want to see how much it went up by, so it went from negative 8.5 to positive 7.6. We want to subtract those two numbers, so we can do 7.6 minus negative 8.5. Second negative is adding, so 7.6 plus 8.5. And you can use your calculator if you need to, but that should be 16.1. 16.1 degrees Celsius. Number 2. Julio lives 3/5 of a mile from school. If he walked 1/3 of a mile already this morning, how much farther must he walk to get to school? So he's already walked 1/3 of a mile. He lives 3/5 of a mile from school. We want to subtract 1/3 from 3/5 to figure out how much further he needs to go. So if you're doing this without a calculator, you could do a common denominator. What could you multiply 3 and 5 by to get to its common denominator? Well, it turns out you can multiply 5 by 3, 3 by 5, and they both give you 15. Well, we'd have to multiply that by 3 as well, and that by 5. So that ends up being 9/15 minus 5/15. 9 minus 5 is 4. So he'd have to go 4/15 of a mile further to finish his walk. Question 3. If the product of 5 integers is positive, then at most, how many of the 5 integers are negative? Well, let's play around with this. So let's see, you got a negative. Product means times, so negative times negative is a positive. So that would give you a positive. All right, so let's you can get a negative times negative times negative. Positive, positive. Well, 2 negatives is a positive times another negative, that's negative. If you do 4 negatives, that's positive because 2 negatives is positive, 2 negatives is positive, all that's positive together. So that times a positive is positive. If you have 5 negatives, that's going to be negative. So you can have up to 4 negatives. 4 of them could be, up to 4 of them could be negative. Does that make sense? Number 4, Mitchell walked 3.75 laps in 18 minutes. If he walked each lap at the same pace, how long did it take him to walk one full lap? So he did 3.75 laps in 18 minutes. If he walked each lap at the same pace, how long did it take him to walk one full lap? So let's see, he did 3.75 laps. In 18 minutes, if he walked each lap at the same pace, how long did it take him to walk one full lap? So one lap in how many minutes? So that's what we want to find. This is a proportion, so we could cross multiply. So we could say 3.75x equals 1 times 18. which is 18. So 3.75x equals 18. Turns out you can just do 18 divided by 3.75, and that'll get you your answer. You might want to use a calculator for that, but that's going to be, let's check my calculator real quick. 3.18 divided by 3.75. That's going to give me 4.8. And what's our unit? Well, that's minutes. So it's going to be 4.8 minutes for each lap. And our last question. Tommy started a new exercise program that requires him to run 12 miles a week, 7 days. On Monday, he ran 3.5 miles. On Tuesday, he ran 1.25 miles. If he chooses not to run Wednesday or Thursday, can he reach his goal if he runs 2.5 miles on each of the remaining days of the week? Well, you basically got to add. So 3.5 miles, honestly, you can just kind of list your days out. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. On Monday, he's 3.5 miles, say 3.5. Tuesday is 1.25. Quarter is 25 cents, so 1.25. He chooses not to run on Wednesday or Thursday. Can he reach his goal if he runs 2.5 miles on each of the remaining days of the week? So 2.5, 2.5, and 2.5. Well, we just got to add them up together and see what everything adds to and see if it's 12 or more. So 3.5 plus 1.25 is 4.75. Let's see, it's 5 plus 2.5, so that's 7.5. So let's add those together. So it looks like, let's see, 11, looks like 12.25 miles is the total. And he needed to run 12 miles. That was his goal. So yes, he met his goal. There you go.